Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So the topic that we will discuss today, it is the general behavior of the alkali metals. So here we will discuss about the behavior of the alkali metals, that what type of reactions they can do and what is their reactivity. Basically, when we talk about the reducing property of an element, it basically depends upon the magnitude of its ionization energy. So when we have a look on the ionization energies, as ionization energies of the alkali metals are very low, and the reducing agent is the one which can lose the electrons. So as their ionization energies are low, so they can lose their electrons very easily. In turn, they are strong reducing agents, which are the alkali metals. So on the other hand, the second property is this: they are highly electropositive. Electropositive mean they can lose their electrons very easily, and in turn they changes into the metal cations that are having positive charge, and then they readily reacts with the halogens, and then they convert it into the alkali metal halides, or simple we can say that they will be converted into metal halides. A very simple example for this we have sodium. When it reacts with the chlorine, it changes into the sodium chloride. So it forms a metal halide readily because it is more electropositive and chlorine is more electronegative. After that, we have the trends in the chemical properties of the alkali metals. Basically, the alkalis group 2 elements, they get react with the ammonia salt, and they form the three type of products. The first one we have salt, then water, and ammonia gas. On the other hand, they react with the acids and they form the salt and water. Third one property is this: they react with the metal salt and they form another metal salt and also hydroxides. So this is the simple trend in the chemical properties of the alkali metals, that they get react with the different substances. On the other hand, they are mainly low ionization alkali metals. So that's why this is the most reactive this is the most reactive family of the metals. In turn, they react very easily and very high. So the cations of the alkali metals, they have low charge and large radii than the radius of any cation. When we have the cations of the alkali metals, they just do changes into the metal cations, and these metal cations have low charge as compared to the simple cations of other elements. So that's why there most of the simple salts of the alkali metals are simple water soluble. So their salts are water soluble, and most of their salts also dissociated into the aqueous solutions, and the hydroxides are among the strongest bases available. When they are water soluble, they get dissociated into different ions, and thus the hydroxide ions produced. These hydroxide ions are strongly basic in nature. On the other hand, when it reacts with the metal salt or any other metallic salt, they produces the other metal salt along with the hydroxide. It is also basic in nature. After that, we have the oxides of the alkali metals. All the alkali metals have their oxides. They can be changes into the peroxides, they can make the superoxide readily and they dissolve in water and they produces corresponding hydroxides which are the strong alkalis. For example, we have the first sodium. When it reacts with the water, it produces sodium hydroxide along with the production of the hydrogen gas. We have this oxide, which is sodium oxide. It reacts with the water and produces sodium hydroxide. Then sodium peroxide, it produces also sodium hydroxide. We have potassium superoxide, it produces potassium hydroxide. All these produces their corresponding hydroxides as these oxides are strongly basic or alkalis in nature. So that's why we can say that the oxides of the alkali metals are basic in nature, or we can say that the metallic oxides are basic in nature. Metallic oxides are basic in nature because when they get dissolved in water, they produce bases. So this is the reason that they are basic in nature. And another example, when the lithium reacts with the oxygen, it just form the simple or the normal oxide. This is known as the lithium oxide. By balancing this, we just get the lithium oxide, which is a normal oxide. It only burns in the air to form the normal oxide, which is basically a white solid. After that, when the lithium oxide is further having the exposure to the carbon dioxide, then it changes into the carbonate, which is the lithium carbonate. So this is the simple oxides of the alkali metals. Then we have hydrides of the alkali metals. When alkali metals reacts with the hydrogen, then they produces the binary compounds. These compounds are basically known as simple hydrides of the alkali metals. As these hydrides formed with the reaction of the hydrogen, these are the alkali metals, and the temperature we have to provide it is 673 Kelvin, and it produces the metal hydride, or we can also say that they are ionic metal hydride on the reaction with the hydrogen. For example, we have lithium plus hydrogen. It produces the hydride, which is lithium hydride. It is very simple. By balancing out this, we just gain that. So this is the simple hydride. On the other hand, when the other alkali metals we talk about, which is rubidium and cesium, they react violently with the hydrogen at room temperature, which is 25 degrees Celsius. But the other three metals require the elevated temperature, which is lithium, sodium, and potassium. They required high temperature or the elevated temperature because their ionization energies are enough to lose the electrons and they get react. But lithium and sodium hydrides, they are useful sources of the hydrogen gas when they just get reacted with the water. So that's why they are very important. For example, when we have lithium hydride, it get reacts with the water at liquid, then it forms lithium hydroxide plus hydrogen gas. So hydrogen gas is liberated by this process. It can be useful. On the other hand, when we have the different hydrides of the alkali metals, they are acting as the strong, powerful reducing agents for the other elements. Along with this, we can also learn the reactions of the halogens. When we have the alkali metals and they react with the halogens, they produces alkali metal halides. Where M, for example, we can take is lithium, and the halogen we can take any fluorine, chlorine, or bromine. Likewise, we take chlorine. Then the product that we just gain, it is the lithium chloride. As the lithium chloride, it is a very stable compound and known as the alkali metals. For example, we have potassium. It reacts with the chlorine. Then the product we gain, it is the potassium chloride, and we can balance it. We have to provide temperature over there. So the alkali metals react easily with the halogens and they give their respective halides. It can react with sodium, lithium, potassium as well. So this was a simple overview about the behavior or the chemical properties of the alkali metals. I hope you guys understand, and if you have any queries, you may ask me about that in the comment section and I will get back to you guys soon. The next topic that we will discuss, it is the general behavior of the alkaline earth metals. For that time, you guys have a good day and keep learning.